in English in a paper. So this is the historical background of the BIM, which we are using it now. It's a very old concept. These are the mandates which we can see across the globe, which is already being a part of implementation for a long time. Various countries are already being, it is mandatory for various countries for implementing BIM, for improving the construction process. Now, these few slides which I'm talking about, when we started, there was a maturity model which was being followed by the BIM forum, where what was the level 0, level 1, level 2. So we have 2D, 3D development. Then we were developing the model part, which is in level 2. And then integrated model were into the level 3 portion, which was normally being followed when we were started with the BIM concept initially. Post that, now when you see, we have various codes in place which can be used for naming conventions or asset tagging or the BIM level of detailing. So these are certain codes which are being used across the industry now, which PAS is publicly available standards right now, and now we have BS codes, EN ISO 19650, which is being widely used in various contracts. So it is now more in a structured fashion. So just coming and touching to these certain very basic elements, what LOD is always being discussed, level of detailing. So it starts from LOD 100, it goes to LOD 400, LOD 500. So as we go for the level of detailing, the level of detailing up to 400, 500, it adds up to the maximum detail possible in the 3D model. Now, the overall concept of BIM development, as Vinay sir has said, it ranges from 3D, which is being a regular practiced by the architects for so many years. Then we are adding a parameter of time as 4D, cost as 5D. 6D is the sustainability, where the energy calculations are being done. And then 7D is the facility management. So these are certain this is the process normally for the BIM implementation is being followed. So what I'm doing here is I'm only focusing on how we can explore and utilize at the maximum level the 3D model which is available to us. I'm focusing only on that part as a part of digitalization. And now I'm getting into the second portion of my presentation. These are certain basics which everybody had in mind. Now I'm going to switch on to the next level, where we have came up with the integrated solution concept, or digitalized integrated solution for the construction industry. So if you see, right now the BIM buzz was there, where the modeling was focused much on the platter. But what we have done, the whole BIM concept is one element of the integrated approach. Second major element, which is a backbone. If I want to make a BIM successful story, then I need to have a strong planning or a construction schedule in place. So my BIM reflects what exactly I'm going to execute on site. And then what we have done for the ease of working, we have created an in-house mobile application in the name of Intento Projects, which is our in-house patented product, to facilitate a site engineer to have a progress reports on his mobile, as well as he can review the models on his mobile or a desktop. So for that, this platform is being utilized. So these are three elements constitute for integrated solution, which are being widely using now. The concept, or what we as a consultants, we are focusing on, this BIM platform shall be utilized from the tender stage till the execution part of it, and going forward for the contract management, and also for the operation and maintenance, that is the seventh dimension of the model. And this is what we have successfully completed on various projects with various clients, which I'm going to now present. So first of all, I'm starting with the case study 1, which is MG Setu. I would like to thank AFCONS, and Giridhar sir is here, who's the Deputy MD of Gammon, for giving us an opportunity to execute this kind of an project for complete BIM life cycle, right from 3D to 5D, and then going forward 6D. And I'm very proud to mention that this is the fastest delivery of BIM across the globe, which we have completed 3D model, construction schedule, and integration with the mobile application in just merely 1 month, 10 days time. So as far as I know, wherever my knowledge or information goes, this is the fastest delivery which we have done it for this project. So what we have done is, there's a Tekla model which is being drafted or given by AFCON up to certain level. The whole 5.7 kilometer is being regenerated with the substructure as well as the superstructure, which was to be reconstructed, that is being completely modeled, geo-referenced and placed at the exact location over Ganga river. So the referencing was first thing, which is the part where the first challenge which AFCONS has given us, I mention that also, that we want to implement a complete beam cycle for this particular project. Whether it is possible or not, please show it to us and then we'll take it forward. And let me mention that we have got complete support right from top to bottom at various levels for implementing this case study. So here if you see, in the detailing part, we have done this is one portion where the pier head is being drafted up to pedestal and bearing. The whole truss spans were mapped, and also the finishing items, including MEP items, are also being mapped in the model. So we have gone up to the maximum level of detailing which is possible to be done in the model for any infrastructure projects. This is just a quick walkthrough which will give you an idea, which is geo-located and placed at the location that even the footpath also is being mapped along with the railing. So all the finer details are being mapped into the model along with the element of the truss. So this is just a quick walkthrough which I would like to show, just to show or give a glimpse of LHS and RHS portion, footpath area, the existing road on the land portion. So we have wet portion, intermediate spans as well as dry spans. So just another view from the bottom, which gives where we have mapped the pedestals and bearings also. So I'll just take a bit ahead because this will go continuously on the 5.7 kilometers of the stretch of the complete alignment. So this is the walkthrough, just to give a feel that the complete project can be seen on the screen while we are reviewing it, and that is being translated, and I'll be showing into the subsequent slide. So this is on the wet portion or the catchment area. So this is a walkthrough for the MG Setu. Now what new we have done, everybody knows we can extract quantities and clash removal, everything, it's not a new thing for that. What we have done new here, that we validated the construction methodology where we have cantilever method and another method where we were having a bottom truss, inner and outer truss, and the top truss. So we wanted to replicate the exact construction sequence. Whatever is happening on site, we should be able to represent that on the screen. So if you see, this is the node-wise development. So every span was broken into 10 nodes. So when I'll go to the next slide, you will see on certain locations, wherever certain portion, half the truss was erected, you will see only that kind of a thing in place. This is where the major failure happens, where the complete span is shown in progress. The second methodology validation which we have done is it had a bottom truss, inner and outer truss, and the top truss. So this is something, the construction methodology validation from a planner's perspective we have done, so which we had in mind that it should help the site plus the delivery process. So the next slide which I am now presenting is, we wanted to identify the bottleneck, and we have wanted to stress on the efficiency of those bottlenecks and remove them. So what we have done is, we have mapped the procurement process also for the fabrication, where we have shown the green color is mainly for the fabrication, the yellow one is delivered on site, and these nodes are being erected. So if you see on the sequence, the simulation, which is the fourth dimension, will show you the exact process and which will be a replica of the construction sequence. So here, including process and the construction progress is being mapped. So this is another flair which we have given to the model, and then for upcoming projects of Male and other things, we are going to do the processes for engineering, whether the drawings are received, procurements are being done. So we are going to go into that level so that we can help the construction project to stay on time. Now, this is the review which we were doing along with the site team as well as with the management. So this is nothing but it shows a progress of the work as on certain date, day number and week number. And what we have done is to identify, to replica the actual progress done on site in the office. We have given the color coding where, as I shown, the truss fabrication, delivery and erection was focused, as well as we have focused on shuttering reinforcement concrete for the deck portion, as well as up to mastic and installation of crash barriers and other items for the finishing. So if I play this, you can see the portion where the crash barriers are done, footpaths are done, trusses were erected, deck portion is pending, was pending for the footpath portion. So the complete project, including we have tagged the pier numbers also, so for easy identification. So sitting in the office, we could review the complete project. So here the shuttering was done, completed. So this way, if I take it a bit ahead, just to save on time, if you see here, what another thing which we have brought into the consideration also is the inventory management, where we have said that wherever we are going to construct the spans, where this is the erection has happened, delivery is in place, so I am not worried about the delay happening on the project because of the procurement. Since the resources are in place, erection is bound to happen. Similarly, we made a provision that at least 3 to 4 spans are in place at site delivered, so there should not be any addition of delay, but we were focusing on mitigation, keeping in consideration the procurement in place. So this is another thing which we have made into taken into consideration, and the whole site was in sync, and then it was presented to the management also. Now going bit ahead on the where I want to show you, so here, if you see, as I was saying, that we wanted to replicate the progress of procurement and construction on the screen. So here, my fabrication was happening, node by node, my delivery was happening. At the same time, if you see yellow, the footpath was also delivered on site. So this way, we were monitoring the whole project, and that's what we could stay on time, and then we have completed project on time as well. So this is the 4D representation of the progress of this site. Then what we have done is, whenever we don't have time, we need to have a recorded progress report. So we have done a delay analysis report also. Regularly we have been doing every 15 days, where what we are trying to project, it's a replica of this model only, where what we have done, if you see, these are the spans. This is for delivery, fabrication, and this is basically for the deck shuttering reinforcement concrete process. If you take any of the span, my shuttering is completed. Then we have cases where my reinforcement was done, my concreting was done, with this case where delay, which is completed but delayed. So we have created the cases wherein we have early start, early completion, early start, late completion, and then we used to focus on mitigation and catch up. So these are the reports also are being created through the model. Then next thing which we have done is we have passed on this model to the site so that they can completely make utilization of the same in various aspects. One, they can check the model wherever they want in their mobile app as well as on the desktop. One. Second, if they want to order the quantity, concrete quantity, or any elemental detail they wanted to check, they did not go back to the design or to the table. They can just access their mobile or the desktop, wherever it is feasible. You can see this P4 to P5 concrete deck, concrete quantity is being mentioned. Similarly, if you see on this location, this is the element of the truss, this thickness, flange plate, their details are being mentioned. So any part of the model they can review standing on the site, and which is being used by the site people also. So this is another next level which we have tried and we have successfully implemented. Then as a part of case, as I said, that this is up to 3D model, 4D and 5D which is being done. Then we have a mobile application which is mainly meant for the MIS report at the site as well as the management. So this report which we are generating was running into 69 pages almost, with the report of delay analysis which I showed, as well as this histograms and S-curves, various analytical report, where we have time, cost, quantity and or resource comparison in a single sheet, which was running into 69 pages or 70 pages. But we were able to roll the whole report in maximum half day's time, and next day it was discussed with site, and in the evening it was pushed to the management. So this was the speed of the generating the report, discussing with the site along with the model, and getting it finding the solution for the mitigation. So here if you see on the reports, as I mentioned, we were giving fortnight comparison for time, planned versus actual and remaining. Here we were giving the comparison of quantities, truss in metric ton, also we were giving in numbers, plus for deck slab also in running meter, numbers and quantity. So any kind of a combination is available on fingertips. So this is what we have done. So any parameter which we want to monitor can be easily monitored on a single click of your mobile or a desktop. So these are certain reports where we were giving the sales value for every month, how much sales I'll be doing in the coming months, so forecasting I would say. Department wise cash flow, what we were giving here, as well as time breakup. Then we were also giving the labor requirements for the site, So wherever how many resources are required month-wise, if you see this month-wise distribution of the resources, here if you see category-wise how many rebar fitters, how many carpenters you need. So up to this level, we have zeroed it down and went to that level of implementation where the resources also can be tracked and monitored. And then there's a next question which comes in, that how difficult this process is. What is being followed is this simple Google Sheet kind of a format which was given to the site. Every week, Friday, we used to get the updated sheets with us, and then the whole process was rolled out in a half day's time, and the reports were ready for circulation. It was that fast. So this is what the overall, why this process was that efficient, is because minimum intervention and minimum data requirement which were asked for at that particular point of time. Then deviating a bit from the case study now, in the mobile app, there are certain features I wanted to highlight. If at the higher level, if you want to monitor the portfolio, what we have done is we have given the project names, given the dynamic delays. This is connected to the Primavera schedule. Then we have given the time and cost comparison. These are the 4 scorecard parameters which are mentioned here, turning from green to red. As my plan versus actual difference increases, my color code changes from green to red automatically in the mobile app, as well as on the cost part. When I say cost, is my sale value from a contractor's perspective. So any given point of time, you have this data available on your mobile or desktop. You need not go back to Primavera or Beam model, anything. So that can be avoided. Then next level information at the management level. What we have done is we have given the drop down for project number, every project of the portfolio, where you can get start date, finish date, and the expected finish date. This is AI based forecasting which we have done. Also the S-curve, planned versus actual and remaining, which is a normal practice. And also we have given the table which is customizable, where we can say what is the scope, 159 crore, how much was the as on date plan, which changes every day dynamically, how much I have achieved, their percentages, and the gap, which this gap is reflected on the top. So this is the second level information we have given to the management in case they would like to get into that. Then this quick video, just one feature of the app which I wanted to present, where what we are doing is you can compare S-curves, histograms, everything on a single graph on a single click. So I'm just clicking on, say, time baseline percentage, actual percentage. So the baselines can be compared, the S-curves can be compared on single graph in terms of cumulative cash flow, plus on your monthly histograms. So all those can be compared like this. So I'm now comparing time baseline percentage, cost baseline percentage. So time and cost, okay. Time and cost comparison, actual and remaining. I'll take a bit ahead. Here you can compare the S-curve as well as the monthly distribution. And if you see the total graph, it will look something like this, where you have plan versus actual, along with S-curve and the histograms both. So on a single click, the engineer's time which is being invested on reports, now it can be utilized in analysis, so that mitigation becomes easy and we can focus on the project completion. So this is how the report, the single graphs look like. So on single graph, everything can be done. Now I'm quickly showing you next 3 case studies. This is a coastal road project for L&T which we have done. Just where we had the various arms of the viaduct, road, as well as the seawall portion. Not clear out here, but so every element is being mapped out here in the project, including road, all the bridges, culverts, everything is being mapped. So this goes on in continuation for the next part of it, where the monopile C portion is being there. So I'll take you to the next slide. I'll just skip the video because of short of time. Here we have done 4D simulation for the road works. So where you can see layer by layer progress happening. So this is the layer wise progress which is being presented, linked to the construction schedule. So this also can be, for this kind of a big projects, also can be replicated on the screen in the office, which we wanted to present here. Then we have focused on something called as smart modeling, because every now quantity takeoff and other things which I have shown were normal. But what we have done is to improve the time cycle of implementation, what we have done is we have used this model or explored this model where we can extract the coordinates for the cable profile as well as for the shuttering coordinates. So we were extracting the cable coordinates from the model itself directly as well as the shuttering coordinates from the model. So it has saved huge amount of time at site. So you need not have a team dedicated to pull out those pointers or the coordinates at site. This is one smart modeling which we have done. This is a quick video of that, where I'm going inside the deck portion just to show how the cables were mapped. So this is the level of detailing which we have done. So I'm going through the span just to give a feel of it. So the detailing was maintained up to the maximum extent on this particular project. Now another project again is AFCONS, where we have implemented the delay analysis also on another project, where our focus is a Mumbai-Pune missing link. This is viaduct 1 and this is viaduct 2, which is cable stay. So I just want to quickly show that. So there's either sides of the mountain, there's a tunnel which is being done by the other contractor. So I'll take it a bit. So it is being completely placed on the topography, and you can see the viaduct 2, which is the cable stay portion, which is being modeled and placed at the location. So those detailings were done. So these are certain final details, and then in here what addition we have done, like cable profile coordinates at the Mumbai Coastal Road, here we are giving the control coordinates for the pylon. So this is something, a value addition we are doing it here. So we are looking at something extra which we can draw from the models so that site can be benefited. So the control points for the pylons will be taken out from here. On this video, I'm just showing a quick simulation, again a validation of the methodology, which is still in the process of fine tuning. So what I'm trying to present is we can explore the model up to the maximum extent what is possible in the infrastructure projects, and the statement can be changed that BIM is also meant for infra in a much more useful manner. So this is just a construction sequence which is being modeled for better clarity. So this is viaduct 2 for cable stay. So this is the simulation of the methodology. I'll go to the next slide. So I have 5 minutes now, or exceeded? But okay, just 2 minutes. Yeah, fine. So I'll just skip this. This is a smart city implementation. So I'll just skip this video. But here we have this Dholera smart city, where 72 kilometers of road network and 720 kilometers of services were mapped. So this is a very 3 years, 4 years back story. So this at that time it is being implemented. Again, delay analysis, how it looks on the screen. This is the progress of the road works which are completed. I'll jump on to the bridge here, where we have done a various cases where I have started early, where I have completed early. This kind of a cases are being mentioned out here at this location. So this kind of a delay analysis becomes a asset for us whenever there is delay happening for root cause analysis or mitigation. So this is another delay analysis focused on this particular road project which we have done. Then we have executed it into the marine project for which is Seabird at Karwar, where again all the jetties or the piers are being shown in this. There are 5 piers which were constructed, and we have gone to the pile muffs, beams, precast segments of the slabs. Up to that level we have done the modeling. Fender fascia walls, cast in situ walls. So all the detailings are being done just to have a better clarity, and this is being simulated in 4D also. So I'll just take it a bit ahead, and if you see this pier 2, we have just skipped halfway through just to show the detailing of the work which we have done it here. So these are 5 piers which were mapped for this particular project. So what I'm trying to say, this also can be used in marine projects, special projects. So this is 2 level of decks which are being casted. So this is another part where the implementation can be done. Again, this is a tunnel project where these models are being done on as-built data, where the overbreak can be mapped. So what I'm trying to say that this complete modeling part can be taken up at any project at any level, which is possible, from design stage to the as-built. Now this is, I'll take it quickly to the last part which I want to show. Now this is the asset management which we are talking about. In the model, I have clicked on this lift-wise breakup. I've got all the information which is RHS, what is a delay, what is the reason for delay. So all kind of information can be tagged here and kept it as an asset for any of the organization, any of the project. So this is basically the asset bridge information model loaded with the complete information right from design till the operation and maintenance. And the last slide which is here is which is the maintenance part. So I have shown you 4D, 5D, 6D is not being covered. So 7D is nothing but the maintenance. So this is the mobile interface of an engineer who is going for the scheduled inspection. He gets the mail on his mobile and the location he also can see on his mobile and he can enter the data there. So this is also planning completely digitalized and this is can be used. So this is a POC basically. So this is not being implemented. We have not yet implemented, but the whole system is being through. So up to what I was trying to present in the presentation is the accent of what we have been perceived as BEAM, how we have implemented across the infrastructure projects, including the smart modeling of cable profile, cable coordinates, shuttering coordinates, as well as control coordinates for the pylons, as well as it can be used for marine projects, tunnel projects. So there is no limit for implementing this. So that is what the complete flair I wanted to show in the presentation. And now there's a main question why we need integrated approach, because demand for infrastructure projects, multiple projects are coming in. Sir has already explained that many projects already are happening in Bombay also. Then fast track delivery is the bottom line for every project. Always, if we control the time, profitability is going to be the byproduct for the same. And then also we want to focus where we have used this delay analysis is mainly to solve the disputes, not to create the disputes. So in nutshell, to suffice the fast track construction and the demand required or expected by the infra projects with less disputes, this is what we are focusing, or we should focus as an industry as from the integrated approach. With this, I would like to thank for patient hearing. Thank you very much. So, Gopal, yeah. So,
hello. Yeah. So we just thought that these questions can better be taken when the mind works better. That will be before the dinner and after the lectures. So you know where the mind works better. Before dinner, after the lectures. So we have the key man, Mr. Brijesh Dixit, with us. A big clap for him. Well, Dr. Brijesh Dixit, sorry. Yeah. So now we'll have the second lecture. Let Dr. Gopal Rai take charge of it.
Let us give a big round of clap to both the awardees, Mr. Tambe and Mr. Dixit. Thank you. Thank you for gracing the event. Now the second talk is totally in the memory of Engineer Kelkar. Engineer Kelkar was our treasurer from 2014 to 2022. And his passion was towards the temporary structure erection. And he was one of the, like, you can say the good book engineer, or in the Bhide Saab's directory or dictionary. So he always used to take the guidance and everything from Mr. Kelkar. And Engineer Kelkar was retired from Indian Railway. So, and two months before we lost him. So we have made the condolence meet online and all. But in the memory of Engineer Kelkar, today we have kept one talk by today's our also one of the founder member and the active IIBE member by Engineer Mohan Jatkarji. Let me introduce let me introduce Engineer Mohan Jatkarji. Engineer Mohan Jatkarji received his civil engineering bachelor and PG degree from University of Pune, India. He joined Gammon India in 1980 as a design engineer, has extensive experience in design of permanent structure, front-end engineering, design of temporary structure. He has handled assignments on a variety of structures like industrial structure, major bridges, marine structures in various capacity. Before retiring as a technical director, presently as an advisor, technical in Gammon Engineering and Contracts Private Limited. His main area of interest are construction engineering, design and construction interface issues, design of temporary works and training. He is member of various technical committee and co-convener of B7 committee of IRC for temporary structure. He is contributing as an author for bridge deck erection equipment, published by Institute of Civil Engineer in UK, a member of work group WG6 International Association of Bridge Structure Engineer. So here I invite Engineer Mohan Jatkarji to give a talk on the temporary structure of bridge construction, some critical case study. Big round of clap to Engineer Mohan Jatkarji. Also, this all in the seminar hall, there is a lot of standees are there of the sponsors, JSW, from the J Kumar and Novi's DGC. They have put some sensors also on the back side. We can see that. So your heartbeat and everything is controlled by Novi's. So on the back side, you can check your heartbeat of the bridges. So live sensors were kept there as a Singapore company. I hand over to Engineer Jatkarji.
Thank you. Dignitaries, ladies and gentlemen, at the outset, let me thank the Executive Committee of IIBE for inviting me for a lecture in the memory of Mr. Kelkar. He was an expert in erection of temporary structures, as Dr. Rai said. So I'll start with my lecture. Today I've been be covering 5 topics, basically introduction, overview of temporary structures for bridge construction, just to make everybody aware of what it is in case they are not. What are failures of temporary structures? Then what critical issues are involved for temporary structures, and then conclusion. So construction technology evolves basically on development of structural theories, then sophisticated equipment, and development and improvement of new materials. So the design and construction methods have to catch up with all this development. Generally, people see the finished structure and they don't pay much attention or think on how it could have been constructed. So this is the temporary structure which was erected, what can be seen on the right, for a bridge in probably Alps somewhere. Construction process involves 2 fundamental activities, that's handling of materials, temporary works and equipment, and then the workforce using their skill uses the above to construct the structure. The term temporary structure itself is unfortunately evoking sense of complacency. This is probably a single most reason why this subject does not get the attention it should. IRC 87, which is also takes inputs from BS code, defines temporary structure as a part of work which allows and enables construction to protect, support or provide access to the permanent works, and which may or may not remain in place on the completion of works. They can also be used in the support of items for a plant, or protecting the side slope of an excavation, or provide access to the workers to the work fronts. There are basically what terminology is associated with temporary structures is the formwork which is immediately in contact with fresh concrete, which deals with the shape or gives it the shape which is desired as per design. False work is the most probably critical item of all these, which supports the permanent structure till it becomes self-supporting. Then there are access scaffolds, supporting structure for plant, and then supporting structure for the sites of the excavation. So we'll just see some photographs which are representative of various types of temporary works. This is a simple structure which was in Park Strait with which has shallow water. So open foundation was possible in that which is Pamban Bridge. So a simple coffer dam is can be done for a open foundation. Piles, whatever I am mentioning is the temporary structure associated with that particular type of construction. So here you can see an end-on piling gantry, which is mainly used for marine piling. So it can progress on the already constructed piles or temporary piles, and the piling rigs, etc., are mounted on that platform, which is moving ahead. There are well foundations in Gangetic plains particularly, where the founding strata can be as deep as 50 to 60 meters below the bed. So a well foundation is the norm in that area particularly. So wells can be constructed in shallow water by just filling up the water body by constructing a sand island, maybe up to a depth of 4 or 5 meters. Then there are barges which support the crane which is sinking the well or doing the mucking operation. For deeper waters, that is more than say 5 meters, a shell which will act like a formwork for the well steening is constructed in the form of a floating caisson. It's fabricated on the banks and then floated into water by taking it to the location either by tugs or through other gantries and so on. Here you can see a pier which was constructed for JJ flyover, about 7 meters. Nowadays, similar concept is being used for constructing much more taller piers. You can see for metro works, similar arrangement. Then coming to superstructure, classification can be done in terms of materials like steel decks, composite or concrete decks. Concrete decks in turn can be in situ precast, that is precast segmental or full span precast. So in situ decks can be span by span, supported by scaffold or a moving scaffold system. It can be a cantilever construction using a form traveler, which can in turn be underslung or overhead, which we will see some photographs later on. Here you can see an in situ construction, typical which everybody is familiar, using some trestle supports from the ground. Here it's a conventional staging which is used for casting the superstructure. Here, to allow for passage of vehicles, a portal frame is formed using high capacity trestles and a truss. This is an example of form travelers which are used for cantilever construction. You can see they are blue colored truss structures which support the formwork for the concrete deck, which is cast in segments of say maybe 3 to 5 meters or even more in some cases. So if the decking is supported by on bearings, then it also needs temporary column supports, which you can see pointed by a yellow arrow. So these are the different examples of temporary structures which I am showing, just to be on par with what I am going to talk further. So this is a cantilever construction for arches using again form travelers and tower supports. This is a movable scaffolding system. So you can see in the photograph. So the whole shuttering is mounted on a supporting system, and the whole span supporting system can move on the trestles. So the time for dismantling and re-erection is saved. This can be done up to spans up to 70 meters. Not very popular in India yet, but it is a quite an efficient method, I would say. Precast decks can be precast beams, full span decks, or precast segmental decks. The pre-tension girders were extensively used for Mumbai flowers, and probably everybody is aware of various examples of this technology. This is just a pre-tensioning bed. You can see the jacks which are used for extending the strands before pouring the concrete. This is an example of erection of beam using a crane. Example of a launching truss using, launching truss being used for launching the precast beams. Here is a case for MTP railways. A full span box was precast and then launched into position using launching gantries. Another interesting example for Vasai Creek Bridge. The entire span, weighing about 800 tons, was cast on jetties and then taken to the location on a barge, and then using the high tide, it was lowered into position. Then we come to precast segmental decks, incremental launching, then cantilever construction can be done by using cranes, lifting frames, and gantries. Span by span construction can be done by scaffold, that is ground supported structure, or lifting frames, or launching gantries. So again, an example of full span box being launched by a sophisticated launching girder. This is a casting cell for a short line method. The red one is the unit to be cast, which is having a bulkhead on one side, that is the left hand side, and the previously cast segment, which is in green, is used as a shuttering for the front face of the. So that's how the match casting is achieved. You can see an example of such a bed. The trickiest part is adjusting the already precast segment in 3D using a special vehicle which is supporting the precast segment. So it can adjust in 3 dimensions. I think MTHL has got far more sophisticated machines than this. Then can be a long line bed where the entire span is set on the bed, and alternate segments are cast first and the intermediate segments are cast later on. So that's how the entire span is set out on the bed, and the geometry can be controlled more easily, whereas the short line machine require sophisticated software for the adjusting the geometries. As I said earlier, segment erection methods can be ground supported or underslung, so which is below the deck, or an overhead launching truss which is above the deck. So this is an example of the ground supporting arrangement. Then when it is taken to the erection site, this is an example of the underslung launching gantry. The segments are being placed on the plate girder, which you can see in the central span. This is an example of the overhead launching truss. Then cantilever construction can be achieved by using, say, floating crane where water bodies are there, or on land, even gantry cranes can be used. So this is an example of a launching truss which can lift the segment from the previously cast span and launch it in the further spans. So this is an example from Oleron Viaduct. There can be lifting frames which can lift the segments from the ground where access is possible. In incremental launching, casting cell is located on one bank, you can see on the left, and the precast deck, which is a continuous deck, is pushed into the further spans of the bridge by a mechanism, and there is a launching nose to control the bending moments which are arising out of cantilever action. So it can also be done for curved spans which are in constant radius, you can say. So this is an example of that, incremental launching. Now we come to the more important topic. What I showed you earlier was just a few examples of the temporary works. There are various surveys being done for failures whenever they occur. This is one such survey done by R.K. Garg and others for failures which have happened in India. So a high percentage is attributed to scaffolding, that is false work, then construction technology, then some disaster related, maybe floods and so on. Then can be design errors, maybe 8% of the whole data, whatever they have collected, mechanical faults, human errors, and in a small percentage of unknown causes. If you see the total, it adds up to 100%, implying that there are no overlaps of different causes. But this is not exactly a representative of the reality. Why? We'll see further. There is a more exhaustive survey was done by Andre and others, basically for his PhD thesis. He was from Portugal, I think. They surveyed 73 accidents across 19 countries and came to these statistics what I'm presenting. So if you see overall statistics, 49% of the accidents, the causes were unknown. This is exactly contrary to what was projected in the earlier slide. This can happen because of the various overlapping causes, which we'll see. They have classified the causes into procedural, then enabling events, and then the triggering events. So procedural causes are related to management issues and the interrelationships between the various parties involved. Enabling events are internal condition or performance of the structure or its components that contribute to the failure. And triggering events are external events that could initiate failure of a structure. So we'll see in slightly further details. Procedural causes are related to the context and to the organizational and management deficiencies. So 8 possible causes they have analyzed. And the most predominant one was the inadequate review of the false work design, assembly and operation methods. Again, overall means other unknown causes, again 44% of the cases. Then inadequate QC procedures and so on. See, if you see here, the percentage add up to more than 100 for the simple reason that there are overlapping causes. So there can be more than one cause, which is generally the case in case of an accident. So what we saw, procedural failures in the earlier slide, so this is just a repetition of that. As 44% of the accidents are, the causes are unknown, it can be concluded that in general several procedural causes may coincide in a given accident, meaning that the failures are rarely caused by one reason only, but rather by the accumulation of detrimental effects caused by a series of small events, then which eat into the safety factors. So this is their conclusion after exhaustive research. False work projects are there hardly any interaction takes place between the permanent designer and the other parties. This is one of the reasons. Frequently, changes in the permanent structures are not conveyed to the others, or changes in the construction sequence are not conveyed to others. Or there may be changes done at the site which are not conveyed to the corporate offices and so on. So all these inadequate ground investigations, all these are procedural failures. Then we come to enabling events. Enabling events which are related to design and operational issues, and mostly both of them occur at the same time. 6 different enabling events were considered. Again, unknown causes predominate the overall analysis. Then design related issues of say 26%. Inadequate bracing, then this is the single most reason for many failures. That is, the false work is not braced adequately. So although it shows only 19%, this is the primary event or reason for many failures, which was investigated earlier also, which we'll come to later on in the presentation. The second most important was under-designed components, such as jacks, couplers, and so on. So they may not be designed to the same values which are as the main structure. So this is one of the. Then there can be incorrect assembly procedures for false work system, which are involved only in 3% of the collapses. However, this is low percentage. Can be an indicator only because the false work, once it fails, it cannot be just, it is just a mangle. You can't see any individual components or pinpoint what has failed or whether there was an error in erection. So triggering events are related to hazards which are due to permanent or variable loads. Permanent loads are obviously weight of concrete and so on. Variable loads include construction loads like weight of fresh concrete, reinforcement, and other materials stored on the deck, then construction traffic and so on. I'll have to hurry up. I think I'm already getting chits which I initially ignored, but I'm sure I'll get some more now. So let me hurry up. Triggering events in general are important loads that bridge false work structures are subjected to from the concrete, and contrary to that, this is the most important reason. Contrary to permanent structure works, which may be subjected to some hypothetical loading only once in a lifetime or a few times in a lifetime, the temporary structures are loaded most of the time to the design loads for which they are designed, and so the failure of temporary structures is higher, the percentage or possibility is higher than permanent structures. So I'll just skip this. So in conclusion, it can be said that failures do not occur from a single error, but rather from accumulation of undetected or badly corrected errors in planning, design, and operation phases. In particular, management of temporary works is essential for improving the safety factors. Then there are not exactly temporary structures, but we have now graduated to specialized equipment which is in probably nobody's domain, so it always lands with the temporary structure designer. These are the sophisticated launching equipment or bridge deck erection equipment as it is seen from this photograph. If this fails, the consequences can be catastrophic and causes a lot of delays and overruns on the project, besides, of course, human life, loss of human life. So it is far more complicated than an ordinary structure which doesn't move. So I'm just referring to this text to which I contributed to some extent. I'll just move. There is a IRC 87 which gives the guidelines for design and erection of false work of bridges. Then there are other codes like BS code. There are a lot of accidents happening in UK, and they formed a committee, formal committee headed by one Mr. Bragg. He investigated and published the report in 1982. Why I'm mentioning this? Because it is surprising that the same nature of errors continue to happen even after 40 years. So the reason for failure of false work, according to him, were design itself is not adequate, loads coming on the structure are not the same as what was designed, and there is a difference of what is happening at site, and the false work erected at site is not as per design. So these are the same causes which were found in the later research done by Baptista and others, what I presented. So it recognizes, that report recognizes there are procedural controls which need to be exercised at design phase itself, then communication and documentation, and site operations phase. So details I am not going to get into right now. The most important thing which it recommends is appointment of a temporary works coordinator, who is of course sitting at site and doing all the coordination for proper planning, implementation, monitoring, coordination and supervision of temporary works, and not design of temporary works, so that there are no gaps between various parties which are involved in the whole process. Again, all these investigation never mention training, or they never mention that there is a shortage of manpower at site. But the reality, ground reality is there is hardly any trained manpower. We are having so many infrastructure projects in our country, but compared to that, what is the availability of trained manpower? Which is a serious issue, which probably everybody is aware, but nobody wants to bell the cat, sort of. So the training is the primary requirement, I would say, to develop this cadre to minimize the accidents, and no amount of documentation will solve this problem. No amount of stricter codes or checklists or anything. If the people don't understand, they don't understand. That's it. So conclusion, suitable type, configuration, design basis, etc. for temporary structures have to be derived from the construction methodology prepared proposed at site. Success of temporary works is not just good design, but it depends on many other aspects like need to achieve time cycles and so on. Of course, safety, cost effectiveness. Bridge, of course, there is a spate of accidents of late, which is a worrying thing, and maybe it is because of largely mechanized solutions which are required for accelerated construction. So this requires a proper coordination between designers and contractors for effective implementation at site. Serious attention needs to be given for training. And thanks for your attention. Any queries? As Mr. Gupta has said, we'll address later on. Thank you.
Thank you, sir. Thank you very much for accepting and giving talk on behalf of Engineer Kelkar in the memory. And thank you. Before Deepika arrange for the stage for the next important part for which we are there in the evening. Let us take two questions for both the speakers. First speaker was Engineer Swapnil Joshi. Do we have any questions for Engineer Swapnil? Can you give mic there? Yeah.
Mr. Joshi, pardon me if my question exposes my ignorance, but essentially I was asking you on your BIM model. Am I audible? Okay, on your BIM model, do you necessarily have to have the drawing separately from an AutoCAD which you interface, and also your program schedule? Do you need something like a Primavera with you can interface, or that's all done within your BIM model?
Basically, the BIM model work starts based on the 2D drawings, CAD drawings.
So it can interface with the CAD.
Yes, that needs to be converted into 3D interface, and then the whole thing which I have shown will be done. And then for 4D simulation, where the model becomes static to dynamic, there you need a construction schedule. It can be Primavera, MS Project, or any other tool which we are using for planning. So then it is translated in 4D, and then we can have a complete digitalization, the integrated solution for that.
So just a follow-up. Is
Yeah.
there a conflict resolution also, because you've got
Yes.
the structures and you've got so
Yes.
many utilities, so that BIM model takes care of the utilities?
So basic step, or the first step of once the modeling is done, when we are calling it an integrated models, all the trades are being clubbed together and become an integrated model. There we can see the conflicts and clashes. So once we remove that, then there is no rework happening on site. So that is the step number 1 which we do, post-modeling.
Okay, thank you.
Thanks.
I think we'll take one question for Engineer Jatkarji. Any questions for Engineer Jatkarji? It's a very important subject. I think what he has quoted, percentage of failures and all disasters happen only because of temporary structure. Any questions for Engineer Datkar? Yes. You introduce yourself.
Good evening all. My name is Upkar Raut from Bolin. Jatkar sir, my question is, you mentioned about this person, temporary works coordinator, which is actually a very fruitful input. So, can you throw some light on how many companies have, implemented this practice? And what is the overlook of it going forward?
To my knowledge, nobody has implemented. That is the reality. See, that's why the management attention is required, for this issue. They think it is an unnecessarily burden on the number of staff at site and so on. Every specialized category, if you project, it is a specialized category. Then this will add to our overhead and so on. But this cannot be seen in isolation. It can be assigned to the planning engineer, say, at site, planning head, say, and he can have assistants. In fact, there are recommendations for supervisors also, means temporary work supervisor. So it's not something which is not happening at site, but it doesn't have the attention or focus or the care which needs to be taken at site. So that needs to be focused through this person. To my knowledge, probably nobody has implemented. I don't know, Mr. Khan, whether you have any L&T.
Yeah, I think.
Something.
I'm sorry. I think we'll go ahead with the main event of the today evening. Sorry for waiting. Let me begin with a good word and good evening to all. It's it's the first time engineering after that we are giving on the award function we are going. And may I request, let us give a big round of clap to both the awardees, Dr. Brijesh Dixit to come on the dais and Engineer S.R. Tambe. Please come on the dais. Please welcome, I request President IIBE, I request to the to the DJ, give a big round of music so that these are the stalwarts of the country. And I think we should salute with all the words. Please. I request them to take a place. Thank you very much for coming. Now I request Professor Surya Prakash to give a flower of bouquets to Dr. Brijesh Dixit. Professor Surya Prakash is from IIT Hyderabad. He is a faculty, also EC member of IIBE. He came all along from Hyderabad for this event. Thank you, Professor Surya Prakash. He is also a civil engineer, bridge engineer. I request Engineer Sahil Matre to give a bouquet to S.R. Tambe sir from DGC, from Novis. Thank you, Sahil. He is a computer engineer and putting health monitoring sensor with the Novis. Thank you, Sahil. We should keep clapping. This is proud moment for all engineers. I think ये मोमेंट आता नहीं और 2 साल पहले तो आया नहीं था. So we should keep clapping for them. Now I request our president, Engineer Vinay Gupta, to read the citation for the awardees. So big clap to Engineer Vinay Gupta ji. I request Engineer Vinay Gupta to read the citation for Dr. Brijesh Dixit.
Good evening once again, and I think all of you know why we have gathered here mainly for. We have gathered here to celebrate the awards for 2 main personalities, I would say, of this country. I don't say they are the only main, but there are 2 main personalities. The Special Lifetime Achievement Award goes to Dr. Brijesh Dixit, IRSC. So, I would first like to read out the citation that has led us to this result on a nomination basis, of course. Dr. Brijesh Dixit, born on 2nd September 1958, he completed his BE Civil followed by PhD Eco. Later he joined Indian Railways Services of Engineers IRSE in 1980. He is an acclaimed railway administrator and an efficient infrastructure builder. Apart from being the managing director of Maharashtra Metro Rail Corporation Limited since 2014, he has been chief track engineer in Western Railways, divisional railway manager in Nagpur in Central Railways, chief engineer construction in Indian Railways, chief engineer safety officer in Indian Railways, and so on. I don't want to read everything and bore you with that. So it's such a big lengthy text. Dr. Dixit has been conferred with awards for excellence in the category of Metro Rail with the Best Multimodal Integration in Urban Mobility of India Conference 2021, Construction World Person of the Year 2020 by Foundation of Infrastructure Research Industries Training, FIRST, so another first. Then of course Construction Council, SAP AC Award 2018, GM's Overall Efficiency Shield for 2 years as DRM in 2013, Energy Conservation Award of Ministry of Power from Honorable President of India, that's a rare honor people get, in 2013, that means 9 years ago. Railway Minister's Medal for Outstanding Services in 1992, etc., etc. Again, the list is very lengthy. Recently, he has been spearheading the important project of 38.2 kilometer long Nagpur Metro, wherein Maha Metro has set a record of completing 25 kilometers in a stretch of 50 months, which I think is, of course, we'll talk more about this record, that's Asian record. Dr. Dixit has pioneered the incorporation of 6D BIM. So I talked about 7D, I was mistaken, but 6D is a long way for many of us to go, but he has already brought in 6D. And I think Mr. Joshi spoke up to about 7D also. There are 7Ds, okay, in the metro projects, which is a remarkable achievement for this country. It is, in fact, this has become the pathway for the 6D, 7D, 3D, 4D, and BIM and all that. And now lots and lots of not only metro, even builders and all, they are following this, which encompasses, apart from the basic structure and architecture and everything, and an MEP and all that, the time, the construction schedule, cost, and I don't know how many more things which I may not be aware of. It is the greatest metro project incorporating rooftop solar energy to meet as much as 65% energy required under RESCOPPP, which that's another term in this model, and ensuring 100% water recycling. So I think that's another gigantic task for this country, where energy, recycling, and the water conservation. He has also been spearheading the important project of 31.1 kilometer Pune Metro. In fact, we are designing some parts of this Pune Metro and also Nagpur Metro, which has 30 stations incorporating the lightest metro coaches, which is another achievement, because when the coaches are light, everything reduces in terms of cost. Your running cost, wear and tear, structure, so on and so forth. A dumping site has been converted to a depot. 6D BIM and 100% water recycling are essential features. So this has become like a USP of Maha Metro under, of course, Dr. Brijesh Dixit, to have the 6D and the recycling. He is actively involved in getting the Metro Neo. Oh yes, I want to discuss with him during the break time now, during the our dinner time. The Neo Metro MRTS project, Nashik approved and implemented. So he wants to have it implemented very fast. I came to know from him, in fact, while talking. Navi Mumbai Line 1, NMML1, also has been assigned to Maha Metro by CITCO. So he is there, or rather they are there, where we are all sitting, and also, of course, other cities of Maharashtra. In recognition of his exemplary services leading to transportation development of this country, IIBE takes pride in conferring the Special Lifetime Achievement Award to Dr. Brijesh Dixit, IRSC, on this day. In fact, this was planned to be held on 31st May 2022, but due to some reason we could not hold it, so official date still remains as 31st May 2022, and it's an award of 2021. So, big congratulations to Dr. Brijesh Dixit. But the world does not end here. It is beyond the, let's call it basic citation. At India level and Asia level, Maharashtra Metro Rail Corporation Limited, that's Maha Metro, has set records in several categories, and some of them are as follows. Heaviest single-span double-decker steel bridge truss, 1700 tons of steel over railway tracks in urban area. In fact, the constructor of this are sitting here, Mr. Giridhar Rajgopalan, AFCON's Deputy Managing Director, and of course, it's all spearheaded by Maha Metro. It's a record India is creating, at least in Asia, if not in the world, longest double-decker viaduct with highway flyover and metro rail supported on single row of piers. You must have seen only about 4 or 5 of them. One in Bangalore under construction, one in Nagpur, which is already constructed, one is in Delhi that is under construction, and perhaps one more somewhere. So double decker means in the same space, we are short of space. India is a very large country, still short of space. Make a highway below, make metro above. In fact, I was told that they are also adding, Dr. Dixit, another 6.1 kilometer of double decker viaduct and flyover right there, just next to the present one. So this will become, if you aggregate a 2, more like 10 kilometers. The whole world may find it difficult to break the record. maximum metro stations constructed on double-decker viaduct, because of course when you have a long viaduct, you have stations also in the double-decker. Metro line commissioning 24.088 kilometer in 51 months, I just talked about it. 51 months and 5 days from 31st May 2015 to 5th September 2019, which is SPT construction. First solar PV system in a metro rail project for integrated consumption. So Maha Metro has submitted entries for Limca Book of Records and Guinness Book of Records, World Record, for the above categories, and Maha Metro is expecting recognition from them. So it's not only actors or presenters or exhibitors and all that who submit their entries to these Limca Book of Records and Guinness. Our engineers and our stalwarts like Dr. Brijesh Dixit, like Maha Metro, and of course many other organizations do also submit entries, and I'm sure they must be recognized and they will be recognized and they will be honored. In fact, to understand these things better, I would request their Director Projects, Mr. Mahesh Kumar, to please explain how these records are being talked about through some visuals. Please, Mr. Mahesh Kumar.
आपका सिस्टम कनेक्ट करना है 1 second please try
Good evening, everybody. Normally, in a public sector undertaking or government organization, carrying out the innovative works, innovation, cost optimization, timely completion, and doing the work in time within the cost, innovation is not possible. But who has made it possible? Our respected MD, Dr. Dixit, has made it possible. I would like to tell you that there are series of innovations we have carried out in Nagpur Metro and Pune Metro. To start with, optimization of the viaduct structure, the structure, what is normally 12.5 meter viaduct, which requires land acquisition, we have reduced it to 8.5 meter. It has saved hundreds of crore rupees for Nagpur and Pune Metro. He has done multimodal integration, best in India. The 25 kilometer metro construction in a record time. Implementation of 5D bin, which has saved Maha Metro 10% of the cost, and carrying out the work within the time. It's a hallmark of Metro. Roof solar top energy for traction. Normally we use the roof solar top for the lighting purpose, but we are using for the traction purpose. Metro New is a new concept. Government of India, Ministry of Urban Development has stamped the specification. Its innovation was carried out by Dr. Dixit. It's a elevated viaduct on with a rubber tire trolley buses on 750 volt DC. The cost has come down from 220 crore normally for the heavy metro of 16 ton. It has come down to 85 crore per kilometer, and it has been appreciated at all levels, including Government of India, Government of Maharashtra. This Metro New project is coming at Nasik, Aurangabad, Warangal, all DPR, we are making it there. So there are series of innovations have been carried out and timely completion. I would like to just present some 2 case study where our MD has contributed a lot, which is a hallmark of our see, this is our Nagpur Metro. Around 4 corridors are there. They are 38 kilometer. Corridor number 1, where the circle is there, that's corridor number 1. Here there was a bridge our metro was coming on the median of the road, and National Highway wanted our Honorable Union Minister, he has sanctioned the flyover also on the same median. So what happened, that median means that we can have either metro or we can have either flyover.
and it was a national highway, so they had a more right on having a flyover there. Our Union Minister, Honorable Minister, has given the idea, which is implemented by Dr. Dixit, and we have innovated, that on a single pillar, on a single pier, the middle level is a national highway, and on the same pier, further extended, is a metro. Now, this is conceived, implemented, and inaugurated. Now, I'll just show you some of this flyover, what we constructed, is having a 4-lane as well as 8-lane. The middle portion is that spine, and the side is a rib there. This is a 4-lane flyover having 19-meter ROW. It's the elevated one. This is a 6-lane. 6-lane flyover is 24 meter. Again, middle one is a spine and side is a rib. And you will see when the construction was carried out, is a common right-of-way median was occupied for both the structure. Then again, the launching girder, special launching girder was made. With the same launching girder was used for lifting the spine for the national highway, and same was used for the metro. And then it was put in position there. It's a spine is kept there, and the spine weight, when it is a spine weight between two piers, is almost 400 ton, and when these ribs were attached, it is another 300 ton. So 700 ton load of national highway was attached to the, it was supported on two pier, and metro load again 400 ton. So 700 plus 400, 1100, and launching girder weight is 400. So almost the pier was designed for almost 1500 to 1600 ton. So this is again, wing launcher. We call it wing launcher. Again, it was carried out from pier to pier locations there. And again, there's, that after putting the ribs and spines, it is lateral stressing and longitudinal stressing was carried out there. The rib size itself is 6.5 meter, the one size. So on a trailer, one only rib used to come in night time. A lot of precaution was taken, movement of the ribs from the casting yard to the side there. Again, lifting it there, stitched concrete, stressing. These are all activities there. And then this is the completed flyover there, and it was inaugurated by our Honorable Union Minister, Mr. Gadkari. And this is the one innovative work carried out by Maha Metro, 3.5, almost 3.4 kilometer long viaduct. And this is the corridor number 1, and another corridor 5.8 kilometer viaduct is under construction. By the end of this year, we'll be able to open that segment also. You can see the Ovachi portal. See, this is also innovation of Mr. Dixit. This Ovachi portal, the metro portal, is a tubular truss. This is the first time in India, it increases the aesthetic of the city there. Another case example I would like to present here is this is again 1600 ton steel double decker bridge. See, across the railway track. And this is a unique in itself, across the railway track in urban area in India, 1600 ton, 4-lane national highway, and for the metro it is not done. This bridge, when it was fabricated in Nagpur only, and it was fully assembled to check the camber and other accuracies. It's a contractor's fabricator workshop. It was fully assembled there, checked the cambers, checked the all parameters. It was then dismantled and moved to the side there. You can see that I think that one of the speakers talked about temporary work. You can see the temporary work. These all are temporary works, all supported on the that over these vertical cylindrical steel pipes. Temporary girder was provided there, and on the top of temporary girder, our main girder was assembled there. Just for the information, our temporary structure, the weight was almost 1000 ton. Our main structure was 1600, and temporary structure work was carried out. Of course, after the work was over, this is all scrap. You can see that these are again temporary work across the railway track. We are taking the blocks, and we have used the Hillman roller. I think this is a Hillman roller. We have I think they have used it, but sparingly it is used. But 600 ton load supported on 4 trolleys, it was another challenge. How to support the entire structure, and trains are passing below the bridge there. So Hillman roller was used there. Again, this these again supported on. If you see the size of the column there, almost on the temporary structure, it was almost 14 to 15 meter high. A lot of cranes were used, a lot of constraints were used, but main part was I want to show you this entire 80-meter girder. It cannot be assembled in one go and moved and pulled to the across the railway track. So it was assembled in three parts. See, across the railway portion, one middle part was assembled, and then we have launched it, taking the block from railways, more than 5-6 hour block, and then side portion were attached. Lot of apprehension was given by the expert that it will not match camber, you will not get. The whole position was very, very critical there. More than 80,000 friction bolt were used there. But it was carried out successfully under the guidance of Dr. Dixit there. And it was the lowering, the whole girder after it was launched in position, it was lowered by more than 3 meter. This is a lowering arrangement. This is a unique arrangement. Again, it is designed by our Dr. Noori from SPA from Mumbai and executed by the FCONs there. The work was carried out in a successfully without any incident. And subsequently, we have carried out the load test using our metro trains there. Again, this has we have submitted our nomination request for the Guinness Book of World Record. We are awaiting some result there. So it is all under the leadership of Dr. Dixit. So in short, it's very short. I was given only 2-3 minutes. I didn't want to receive the chit. So I thought I will complete it in time, sir. It's all great goes to Dr. Dixit. Thank you.
Thank you very much, sir, for giving a glimpse towards the future Limca Book of Records, the project. Thank you very much. Now, let us, I think you are aware that this event is going live. Not only 80 people are here, I've just checked online, more than 1,870 people are watching this live award show because of the COVID norms. Okay, big round of clap to all. So now, the moment has came, and to the first awardee, Dr. Brijesh Dixit ji, I request Dr. Harshvardhan Subbarao, Chairman MD of Construma, to give a award to Dr. Brijesh Dixit. Let us have a round of clap with the standing ovation. Let us have a standing ovation. In civil engineering, we stand for 12 hours on the site, and this is the moment. On behalf of IIBE as a EC member, big congratulations to Dr. Brijesh Dixit. Really, it's a big moment, and big moment for IIBE also, and big moment for the family, big moment for the engineering fraternity. So I request big round of clap. These moments are countless. Thank you, thank you. I request Dr. Brijesh Dixit to say few words.
Good evening, all eminent engineers present in this hall and also joining online. Mr. Tambe, and I keep hearing about him from Mr. Gadkari very often. I told him. First of all, my hearty thanks to IIBE, its Director General, its President, all the Executive Committee members, all other members, all others who are associated with IIBE for this honor. But this honor truly goes to the teams with which I worked throughout my career. As you know, there are always people above you, there are always people below you, and there are always people equal to you when you work in teams. I have always supported the idea that there is no winner in a losing team, and there is no loser in a winning team. So always make your team win. That has been the idea, and I always tried to make my team win. And I see same thing in IIBE, doing a wonderful work. I spoke to Mr. Gupta, Mr. Devite. I knew him for so long, and Mr. Gupta as well. And I really salute today and pay my regards to Mr. Bede. At one time I reported to him, and truly remarkable person, I must tell. Even after retirement from railways, for 30 years actually he worked for this organization. And I really salute the present team that they are carrying that legacy forward. So I was just speaking to Mr. Gupta and also Mr. Devite as, India is, in fact, and for 100, maybe 180 years earlier, the bridges on Ganges and bridges on Brahmaputra and bridges on Godavari, even today, you get frightened actually by seeing the magnitude of those bridges. And those bridges were made so long back when the equipment which are available today, technology which is available today, were not there. The other day, when we got these Asia records, which were just mentioned, so Mr. Gadkari was there himself, so I was telling that whatever infra we are making today, they all must be making records and breaking records because of the technology which we have, the materials which we have, the designs which we have. They are all superior to what were earlier available. With all those things, whatever we do, it should be far superior, far bigger, far quicker than what it used to be earlier. So every single infra which we make should make, rather must make, a new record or break a record. We see I keep always telling that, see the VT building, how perfectly it was made at that time. I was very closely associated with that building. I sat in that building for very long, and I was in charge of that building for very long. Every single nook and corner and the column and beam and floor and whatever you may see, even it was commissioned in 1888. It was made by those Angrez who didn't know. They came with only drawings from their country, and they got this building done by our countrymen, whose language they didn't know. How they must have communicated and got the perfect work done. And we are not able to do the same. And that is the challenge of infrastructure today. We must get the highest quality done by the people who are working for us. So we must train them, or we must refresh them, or we must guide them, supervise them, whatever is required should be done. And that is the quality, flawless quality must be strived actually And if it, certainly we make efforts, certainly we will get it. So I'm for the Mahesh, I am thankful, and a lot of my teammates are sitting here and doing wonderful job in Nagpur and Pune metros, and there we have been able to do all these works. And certainly this team which is working for me is because when you near your end careers, when you move towards that, you are at the top. So, and that is where the your responsibility increases. So whatever you thought as a junior person that should be done, now it is your turn to do all that. So I'm thankful to all of them for doing wonderful job and being present here. And thank you for this small presentation. And thank you IIBE once again and all of you who are present here. Jai Hind.
Yeah, thank you very much, sir. Let us have a big round of clap to Dr. Brijesh Dixit. Now we go for the second awardee. Before that, I request Engineer Vinay Gupta to read the citation about Sri S.R. Tambe, but I need more louder claps and more louder claps throughout the presentation. They are the stalwarts of the country, and we should not silently watch the award function. It should make like noise or anything. So I request all of you to make a good noise. These are the engineers. Our construction site work like anything, and we are silent in the award function. So it doesn't suit to our civil engineers. So I request Engineer Vinay Gupta to read the citation for Engineer Sri S.R. Tambe, but I need before that a big round of claps or
It is such an honor for me to read the citation of a person whose name I have only been hearing. And it's an honor for me today, and I am so delighted that I am seeing the same person right in front of me, perhaps the first time. I do not remember any incident in the past. So, sir, with your permission, I would like to say about whatever I have learned about you. This is a Lifetime Achievement Award to Shri S.R. Tambe. Shri S.R. Tambe completed his BTech or BE Civil Engineering. At the time it was more called as BE in 1960. I was not even born honestly. An MSc Engineering in 1962. Even then I was not born. This is the time when our MD Professor Mahesh Tandon completed his BTech from IIT Roorkee, or BE, let's call it. From not IIT, University of Roorkee. He is FIE and IIBE, so that's an honor for IIB that he is associated. He is a past Vice President of Indian Roads Congress and ICI both. I am the President of ICI, so I have a good association now, a person I am with. He's also a member of ISSE. He was the Chairman IRC Committee on Section 4 of Bridge Code and member of IMRA Committee. Shri Tambe joined Indian Railway Services of Engineering in 1961 through UPSC, that's a normal process. But he realized that he had a larger amount of love for Maharashtra. So he left it for Maharashtra Service of Engineers. When he was selected by MPSC, he joined Maharashtra PWD as Assistant Engineer in MSc Class 1, finally promoted as Chief Engineer in 1988. That's the year I got married. And as Secretary to the government in 1994, and then he retired, of course, in 1997. He worked on important projects like Yeldari Dam, prestigious work like survey and DPR of Pune and Nasik Expressway, the Thane Creek Bridge, that's 2 kilometers long in the river or in the sea or creek, is a big job. Several creek bridges in Maharashtra and in Konkan. World Bank aided road projects, Maharashtra's first BOT project, which was a very difficult thing to work out because how BOT would work. We only heard from abroad, but to bring it in India was a difficult task. He took part in framing the successive 20-year road plan and 3-year, 5-year plan for roads of the country. As the chairman of committee which framed design criteria for flyovers in Maharashtra, resulting in large economics conceived, which served as inspiration for the entire country. I believe Mr. P.L. Bhongirwar, who is here in front of us, who was the managing director of MSRDC, when I met him first in MSRDC, perhaps he would have been involved in the same projects, if I'm not wrong, sir. Sorry if I'm wrong. But I think I see a connect between Tambe Sahab and between you, Mr. Bhongirwar. He became the chairman of Accident Prevention Committee and inspected 29,000 kilometers of state and national highways, 29,000 kilometers. As a result of the measures suggested by him, the accidents and death on the roads in Maharashtra came down at that time heavily. He was a member of the Committee of Planning Commission on Road Accidents and Injury Prevention. He was the sole technical member of the Committee on Rural Roads, on which the Pradhan Mantri Gram Sadak Yojana was started under the chairmanship of Honorable Shri Nitin Gadkari ji. So you know why Gadkari ji talks about him so much. There are reasons for it, valid reasons. He is chairman of Technical Advisory Committee of MSRDC, MMRDA, for Worli Bandra Sea Link, Warsaw Bandra Sea Link, Eastern Freeway, etc. He is member of MTHL Committee of MMRDA, Northern Coastal Highway, Expert Committee, Metro Works, the chairman of the Standing Committee, Advisory Committee on Roads of MCGM. We have one person, Dr. Vishal Thombre from MCGM. He was arbitrator in over 80 cases of the government, PSUs, etc. Government and PSUs. He has worked on several disputes resolution boards and committees of PCMC, MMRDA, SIDCO, Steering Committee of MSRDC, etc. So with all these credentials, I would say in recognition of his exemplary services leading to infrastructure development of this country, IIBE takes pride in conferring the Lifetime Achievement Award to Shri S.R. Tambe on this day. Once again, I say 31st May 2022 because that was the official date when the award was announced for 2021. So, hearty congratulations, sir. And I know whatever I have said is probably a minuscule of what is actually done. I keep hearing a lot about him. So when we asked him, sir, can you frame up something for us? He said, this is fine. I said, sir, this is much lesser than what we hear from you. He said, it's not theek hai bas. I don't need more than that. So such a simple person Shri Tambe is. Yes.
I think the moment has came. Although Engineer Vinay Gupta ji has introduced so briefly and he has completely, if we go ahead with Engineer Sri S.R. Tambe, we can have a good civil engineer book on from the administrative sides and from the engineering sides and all part. So I request now our Director General, Engineer Divte ji, to give award to Engineer Shri S.R. Tambe ji. Big round of clap. Big round of clap. I think we should have a standing ovation for Engineer S.R. Tambe for his remarkable achievement for the nation, for the country. The both of them are the tricolor sun for the country. Really, it's a proud moment for the family, for the subordinates, for the colleagues, and for the engineer. Thank you very much. Thank you, sir. Thank you, our Director General, Divte sir. I request Engineer S.R. Tambe ji to say a few words. Thank you, Director General.
Ji, Mr. Dute, Mr. Joshi, Dr. Dixit, and many dignitaries present in the hall. I greet you all. I am overwhelmed by this honor bestowed on me by you all. The honor is especially big because country's most big name bridge engineers are in the IIBE, and they have done many momentous, large, innovative works in all corners of the country and also in the world. Therefore, this honor has special value to me, and I cherish it very much. My large family group spread all over the India and the world is very happy at the event and is showering me with congratulations. I am especially happy because maybe I may be the only person in the hall who was present when IIBE was conceived. There was a meeting held by Mr. Brijesh somewhere in 1980s where all the big name engineers in Mumbai were present. And ultimately, some people opposed, some people supported, and then it was decided to establish IIBE. That because many felt that that was the platform on which bridge builders in various disciplines would come together. There was opposition from some quarters thinking that it will pose a danger to the IRC. But we kept on assuring them that this is not a competitor to IRC, but this is a way to bring in bridge builders from railways, roads, irrigation, water supply, all disciplines together on one platform. And it really has helped a lot. Otherwise, probably many of us road engineers would not have known any railway engineers or people building bridges in irrigation department also. IIB has been immensely helpful in that aspect. I have many memories of my career, and I will take this opportunity to say one or two incidents which may amuse you and which I remember very much. The first one is Mr. S.B. Joshi. Who doesn't know him? He is the doyen of bridge engineers in the country. He happened to be my examiner for my oral viva in my BE examination. I remember that event very much. He was there in his khadi clothing, cap and a bandi, and he asked me several questions. Ultimately, I passed BE, and later on, I became the design engineer for Government of Maharashtra in the design circle, and I was there for about 10 years. But one day I was surprised to see Mr. Joshi walking into my chamber. He was building 3 bridges for Maharashtra at that time, and there was a problem in one of the big bridges across a creek. And he wanted to discuss that. He wanted to get the design approved. So I remember having discussions with such a great man for about an hour or two about that particular design problem. And I'm really amazed that such a big person very humbly discussed all the problems and we arrived at a solution. That is one incident remains in my memory. Second incident is I was in charge of the Thane Creek Bridge, chief engineer. We were building the new Washi Bridge, which is now in use, and the whole traffic was going on the old bridge, which was said to be in a very bad condition. It had suffered tremendous corrosion damage. And of course, the engineers of Mumbai and in Maharashtra, they devised ways to strengthen it. We have one Mr. Manzure who was part of that team at that time. And that bridge, I am happy to say, has survived even today and is still carrying traffic. But at one time it was so bad that whenever I went to any wedding reception or anywhere, people would come and ask me whether that bridge was safe. They would say that they are saying Ram, Ram, Ram while crossing that bridge. Such was the fear in the mind of the people. But what I wanted to tell you was that in one monsoon, when the new bridge was not ready, I received a call at about 12 o'clock at night from the Honorable Minister PWD. It was raining cats and dogs, what we call as a traffic stopper rain in Mumbai. You all know it, how bad it can be. You couldn't have moved out of the house if even you wanted to. The minister said, Tambe Sahib, I am told that that bridge, that pool khachala, that means it has sunk, Thane Creek Bridge. So I was stunned. He said, who told you? He said, some people are telling me that it has gone. So I said, wait, I will let you know. And you know how God helps. Even in that rain, Mumbai's telephone system was working. So I phoned our Chaukidar of the Turbe Godown, which is on the other bank. Luckily for me, he picked up on the second ring. And I talked to him. I told him, don't close the call. Just listen to what I am saying. You go on the road and see whether traffic is plying on the road. And come back and tell me. So he went, he saw, and he said, Sahib, the traffic is moving normally. Then I heaved a sigh of relief and phoned the minister to tell him that there's nothing wrong with the bridge. Another very incident which I will never forget is, it was about 8 or 10 days after my bypass surgery. I had returned home and was lying in bed, resting. At about 10 or 11 o'clock at night, I get a call from Mr. Haridas. Many of you must have known him. He's a great friend of mine also. He said, Tambe, I am very much afraid. फार भीती वाटते मला. काय झालं? What happened? He said, entire traffic is plying on that old bridge. The new bridge had opened actually at that time, but the entire traffic is plying on the old bridge. That all the 4 lanes of that bridge are chock full. Buses, trucks, everything is on that. And it is jam-packed and it is moving very slowly. I am very much afraid that something will give way and it will collapse. So I said, I will see what I can do. Again, luck favors. I phoned our chief engineer, special project at that time, Mr. Jangde, who later on became secretary to government. I said that this is what I hear. And he was staying in New Mumbai, that was the advantage. So I said, I want you to go contact the police and stop traffic on that. Half an hour later, he came and said, yes, I have succeeded. I have talked to the police, and the traffic on the new old bridge has been completely stopped. It has been emptied. So that was a great relief. That was something which I can never forget. Of course, there are so many things. One very small, last, light-hearted memory I have of my young days. I was executive engineer at Amravati. And a new road through thick forest from the place called Harisal to another place called Akot was transferred to PWD from Jilla Parishad. And we took it over. And as soon as we took it over, I said, let us go and inspect it and see what needs to be done. As we were traveling, I was getting down at every bridge and CD work and inspecting. At one bridge, it was a slab bridge, all rocky foundations. I found that there was a hole on one side of one pier, a deep hole. And then I saw that's pretty deep. So I said, let us see what is wrong with this. Actually, that pier was acting like a lintel on that big hole. So I jumped into that hole. And I could go under the pier and come out from the other side, and I got out. But now, years later, now I wonder why I didn't even stop to see whether there was any snake or anything inside it. There could have been, but fortunately I came out safe. And we found that somehow a very big hole had formed. It was a hard black rock foundation. How that hole must have formed under that pier is a mystery to me. We, of course, immediately concreted it and filled it and made it safe. Such amusing incidents occur. And lastly, I would like to mention, we were building a bridge across Atsara Creek in Konkan. It's an old work abandoned by the old contractor, allotted to new contractor. And when I went to the site, we found he had done some wells half and then left it. The new contractor was tackling it. But to my surprise, I found that from several wells, very big, that quartzite type rock, lintel-like pieces were coming out of that well. The well had been completely filled with such type of pieces. How they must have flown in that flood and filled up the well is a mystery to me. Of course, I must compliment the new contractor who completed that bridge very well. I mean, I could go on and on. With age, probably one likes to reminisce. One more thing I would like to say. One of my junior colleagues, who also happened to be my contemporary of my younger brother in IIT, Mr. Bongirwar, is present here. Actually, I am very much touched to see that many of my old colleagues have come here, especially for this function. But with Mr. Bongirwar's help and encouragement maybe, I remember that we introduced 3 things in Mumbai at that time when the flyover project was taken up. One was the rotary pile drilling rigs. If you remember, before that time, whenever there was any building work, we used to hear big hammering of piles and tripods and all that. But we had visited Bangkok and seen the flyover projects there. And from here, we decided to make it compulsory. Second thing was making ready-mix concrete compulsory, because site mixing in Mumbai was a nightmare. So immediately you can now see so many ready-mix plants all over Mumbai and India and everywhere. And third thing was introduction of the reinforced earth retaining walls. Actually, in earlier project, a reinforced earth retaining wall for returns was proposed by one contractor. But at that time we did not have the guts to accept it because we had not seen one. And that place was located in a very busy section of Mumbai. So what I thought was, if supposing it fails, then what happens? But later on, after a visit to Bangkok and Indonesia, we saw that this for ourselves so many RE walls, and now they are the rule. I think I should stop now, and I thank you all once again. Yes. Yes, yes. I have been asked to talk about that ultra high fiber reinforced concrete. You know, this one developer, I think Shinde's, they came up with the idea of using, or whatever that thing is. And they had brought one gentleman from Malaysia, said to the Honorable Minister. The Honorable Minister, Mr. Gadkari, he asked them to see me. So they came to my place and made a short presentation about that type of very high strength concrete. I mean, I think 140, M140, what does they call it? 120, 140 like that. And I found it very attractive. And that has been used successfully in Malaysia. So I recommended to the Honorable Minister that this can be done easily. So he was good enough to immediately set it in motion, and through several meetings in Ministry of Transport, and he sent a team of us to Malaysia to see. Actually, Mr. Bongir was also slated to go, but ultimately his health didn't permit. So we, 3 or 4 of us went there. We saw the factory. We saw several bridges built by them there. And we were very much convinced and impressed. And we recommended that it should be used. So it has been used in one bridge near Latur on a national highway. Actually, they wanted to build a 100-meter span, single span. But the ministry was not so confident. They said, let us start with 50 meters. So they made 2 spans for that bridge. And I think now it has been open to traffic. And now they have, I think, set up a factory also near Pune to cast those things in India. For that Latur bridge, I think they imported all the precast pieces from Malaysia, landed them in Chennai, and from there they were transferred to Latur and then erected there. It's quite a feat. For those who may not have seen that, let me tell you that the webs are very thin because there is no cables inside the web. They are all externally stressed. The cables are inside that box. And the weight is very much reduced because the thickness of web, instead of 12 inches minimum which we use, they are only 6 inches thick with flanges to make them stiff at different distances. So it's a great revolution, and I'm told now it is being used very widely everywhere. And because it has a lot of those fibers, steel fibers, it's very ductile. I mean, it doesn't crack. And I think because of its very high density, it's totally impenetrable. Water probably cannot go through it at all. It is so thick.
Thank you very much, sir. Big round of clap to Engineer Shri S.R. Tambeji. Thank you very much, sir. It's a proud moment for the country, for Maharashtra, for all the engineer fraternity sitting here. Now I request Engineer Sri Girdhar Rajgopalanji to felicitate today's our speaker for the days to Engineer Jatkar and Engineer Swapnil Joshi ji. I request Engineer Girdhar Rajgopalanji to come on the dais, please. I request Engineer Jatkar ji to come on the dais. Let us have a big round of clap for Engineer Jatkar ji for giving a wonderful talk on the temporary structure for the Kelkar Memorial Talk. Thank you very much, Engineer Jatkar ji. Now I request Engineer Swapnil Joshi, the second speaker on the Paramera and the project planning from Intento Associate. Congratulations. I think it's a moment. One of the Vishwakarma of Indian construction industry, or the Bridge Vishwakarma, I will say, organization is Deputy MD is with us, Engineer Girdhar Rajgopalanji. So I will hear from him a few words towards the whole award function, everything. Engineer Girdhar, one of the Bridge Vishwakarma of bridge engineer and construction industry. Let us have a big round of clap to Engineer Girdhar.
Good evening, distinguished chief guests, my fellow colleagues and engineers. It's my privilege today that I've been invited here. And when I entered, I was sharing with Mr. Vinay Gupta my first meeting with Mr. MC Bide. It was in a small office in Mahim, where I first met him as a very young engineer from Afghans, trying to go and meet the then ME to see whether they will permit us to use ready-mix concrete at a cable-stayed bridge which we were going to build in Krishnarajapuram at Bangalore. And the amount of help that Mr. Bide gave me, he actually accompanied me and the then MD, Deputy MD of Afghans. We both, along with him, went and met the ME. We were asked to make an SOP for RMC, and subsequent to that, in the railway project, sir, in Bangalore, RMC Fletcher from New Zealand was given the opportunity to supply concrete. It was, I think, a big moment that a change happened in the industry. I would always cherish my memories of doing bridges. The bridge is a signature to a country, to a city, to a state. And more bridges are coming up in India, challenging bridges, new materials, new technologies. And one word which I appreciate and take from what he said was about the TWC. I think, yes, I, as a contractor who has been doing the back-end engineering and the construction method engineering for our organization from 1980, I really appreciate, sir, that you have actually brought this into the focus to the industry. I think a lot of success on the projects in infra happens because of great construction methodology. So I also would like to take this opportunity to thank sir, because these are leaders who actually give us a platform to innovate. They are willing to accept a few failures, but are willing to support us in times of our need. And the moral boosting support that we get from such officials is what drives us to deliver and raise the bar in our country. I have been proud to have been associated with one iconic project That is the Chenab Bridge, which we are constructing on the Himalayas. It's going to be the world's tallest bridge. Sir, to just share with you, I did make a presentation to ICE on that. 3 lakh bolts, HSFG, 32 dia, 34 dia hole, not a single hole mismatched. And the pier, which was 127 meter tall, erected at the top on a 40 meter concrete pedestal, was only off center by 27 millimeters in the transverse direction. So what I want to say is that was Atmanirbhar, because the complete construction engineering is done by the Indian engineers, though the permanent design is done by international consultants. So I think, sir, IBE and such forums, actually motivate us as engineers to deliver for our nation, and I'm sure we will be very, very ahead of the world in a few years. So I wish all of you a very pleasant evening. I shouldn't stand between you and the dinner. So thank you very much, sir, and I would also like to thank the managing committee for IBE for giving me this opportunity to come and share a few moments with you. Thank you.
So just a last 2 lines from my side, because we are all practicing engineers, whether we design, we construct or supervise or whatever we do, quality control, etc. We design, we make mistakes. We construct, we make mistakes. We do the quality control, we leave certain shortfalls. Only when we do work, we make mistakes. If we don't do work, no mistakes, as I told you earlier. So first of all, when we design, when we have to construct it, you have a stalwart, Mr. Swapnil Joshi, that's a BIM and project management person. Please take help of Mr. Swapnil Joshi. He is a stalwart in this field and also, of course, a very active person in IIBE. But when we have done all this and made some mistakes, what do? We don't just say demolish the structure and discard. Then we take help of Dr. Gopal Rai, DGC, his company, and he would come and make the structure even stronger than what he wanted to design and construct it for. So just wanted to tell you these words because these guys are really very, very, very useful and they're being used heavily in this industry. Yeah. So I think we had a fantastic event, but as a mark of formality, I would still request Dr. Gopal Rai, the Master of Ceremony, to propose a word of thanks. Dr. Gopal Rai.
Thank you, sir. Thank you, President. Next 2 minutes, it will be fast forward. Let me thanks to today's chief guest, Sri SVR Srinivas. On behalf of him, Baswaraj came. Thank you very much for making your presence, and we really thanks for sitting all along the way from since evening to the full complete function. This is a good gesture from MMRDA. Let us have a big round of clap to this chief guest and to Baswaraj. Let me thanks to today's 2 awardees, Dr. Brijesh Dixit and Engineer S.R. Tambe. The big round of claps, the 2 awardees. Let me thanks to our President, Engineer Vinay Gupta. Let me thanks to our Director General, Engineer Dute. Let me thanks to today's 2 speaker, Engineer Jatkar, Engineer Swapnil Joshi. Let me thanks to today's sponsors, Jay Kumar, DGC. I'm taking pause so that you can think about them. Okay? And then JSW. Let us big round of applause to all the sponsors. Really, they have a noble cause they have done by sponsoring this award function. Let me thanks to all the delegates, to all the office bearers. Let me thanks to all the hotel management. Lord, let us thank to YouTube and all the social media partners. Let me thanks to Huzefa, who is our online the scrutiny officer. Let me thanks to all the EC member of IIB. Let me thanks to all the people who will serve now the cocktail and dinner. With this, let me thanks to all the people here. If I forgot anyone, please excuse me. But let us meet for the mega event. This is just a trailer of IIB award. In the coming year, you will see the mega award function. So let us, what Engineer Girdharji told, made in India, and we should make in India. So with that note, Jai Hind, and let us stand for a national anthem of before we close the event. I request the DJ to slow down the music and play the national anthem. I request all of you. जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाए तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय 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 हे भारत माता की. Thank you. We close here. We all invite for a cocktail dinner besides. Thank you very much. Thank you all. I request all the EC presence EC member to have a photograph with the awardees.